That's okay. Well, welcome. Good morning, everybody. As Al, oh dear, stated, um, welcome to the opening session for the AI track here at this GSE UK Virtual. Um, yeah, as Al said, I'm co-chairing this stream together with Al. So I got the shorter straw, so I get to open this track. Al, you're up next year. So, oh, there's one more person wanting to admit, but I can't press the button here. Can you get
Sorry, I'm on it. I'm on it.
just on time? Good morning, everybody. So this session is titled, punningly, I, what has Turing started? Just to get you a bit of a startup on all the AI stuff that's going to get past you these coming days. We're going to try and begin at the start, bring you up to speed what AI has done over the, well, since the start of computing, basically, so that you are maybe more ready for the more awesome presentations to follow in this track. Because it's so early, normally there would be some donuts, but unfortunately for all of you, this is a virtual, so you're just gonna have to do with a virtual donut. My apologies, I hope you'll enjoy. Quick introduction. This is me, but you can see me probably in the screen as well. I like computers. I've liked computers for a very, very long time. This was the first machine I got to play on. Maybe some of you recognize this. If you do, wave out in the chat or request to unmute. It's always cool to discuss techie things. But this is a BBC Micro, very, very powerful machine for its time. I think nowadays my light switch has more CPU power than this thing. As I upgraded my hardware, we moved into the Commodore 64. Very awesome machines. They actually had disk drives and joysticks. It was really, really cool stuff. This one's probably only known to Europeans and Canadian people, and maybe even just the Dutch and the Canadian people and the Germans maybe, but it's an MSX. I don't even know what the acronym stands for, but Philips made them, Sony made them. As you can see, they have a nice built-in floppy drive. You could move the keyboard up and down. It was an amazing machine. Up next, the Commodore Amiga, also a very, very powerful machine compared to the previous ones. All of a sudden, the internet became a thing. I really love those things. You can see I was already doing some mainframey stuff, as there's a couple of IBM books there to the right. Yeah, computers are kind of my thing. Here's a couple of recent ones. The one at the top right corner is actually a small form factor of the same machine we started out with. It's also a BBC Micro, but then I think it's on an ARM processor, but it's about the size of a credit card. It's a really, really cool machine to play with. The one on the left is for doing some security assessments on Wi-Fi networks. And the one on the bottom right is a handheld Linux terminal. Very Star Trek-y, at least to me. But of course, my favorite computer is the mainframe. That doesn't look like this, but looks more like this these days. When there are the mainframe discussions, this is the picture I usually bring up. You can find those in the slides and use that to tweet out sometimes. There's one more person in the waiting room wanting to enter. Al, could you let that person in, please? Cool. Welcome. Good morning. If you would like to get in touch with me, here's some of my contact details: email, Twitter, GitHub, LinkedIn. Just a quick introduction. Besides my love for IT things, I'm an IBM champion since 2019, I think. I'm the co-chair on this AI track for GSE, as we already said. I'm also doing something for the Dutch GuideShare Europe. Proud starter of the Ziggy open source framework. I dabble a bit with a company called Z DevOps. And as of short, I'm also a proud co-founder of the Mainframe Society. You're in virtual room 3. session on the left, after this introduction session in our AI track, there's an amazing session by Eddie Rowe. I will invite you to really watch that one. Then tomorrow, unfortunately, maybe a bit too early for some of us, we have another couple of sessions for you starting at 9 UK times. Another good 3 sessions that you can see here. You can see all these on the agenda on the conference website anyway, or on Bring Your Own agenda. And then we close off Thursday with David Lee on a very nice session. Of course, we'd like you to stay in the AI track, but from experience, it's always nice to look at some other things as well. The good thing for this virtual conference is that everything will be recorded and you can replay them afterwards. So definitely have a look around today, tomorrow, the day after tomorrow, or in the week after when the downloads are ready. Yes, well, AI, there's some people who think this sign is very applicable to AI, that it's dangerous and it's, you know, AI is going to take over the world. I hope today and the coming days in all these sessions that we can kind of get rid of that feeling. So before we can start talking about AI, we have to start talking about the dawning of computing. I assume everybody knows what this is, one of those ticker tape robot machines, Turing complete, as we call it. It's a very simple machine. It can move that big ticker tape of blanks or written stuff from left to right through the I/O unit, that little box in the middle. That box in the middle can either read the data, so a 1 or a 0, or it can write the data or replace the data. And then you write programs that, you know, basically say move 1 to the right. If there's a 1, move 2 to the right and write a 0. And then anything you can do with all the modern programming languages, you could theoretically do with this machine, albeit the graphics are a bit less and probably processing speeds are a bit less. But as long as your tape reel is large and big enough, you can compute anything that you could compute on machines from today, probably except the quantum machines. Here you see another little dynamic of such a universal Turing machine. It's basically a state machine where state is stored in whatever it sort of reads on that tape. The magic word there in the left is obviously infinite tape, because, you know, for larger computational things, you probably need infinite tapes, but theoretically it runs everything. Not Doom, I think. So we're in the year 1948 when Mr. John von Neumann stated that machines can do everything, right? It was the dawn of computing. And there was this big struggle of machines can't do X, and computing machines, they didn't really call it computers then already, can't do X. And John was one of the first to see, well, if you can precisely specify, you know, give me good specifications of what the machine cannot do, I can create you one that can. A very brave statement. Then over here we have Alan Turing at the ACE Pilot Model 1950. Yes, this is what large computers looked like back then. We're talking a machine that fills a room and that had 512 bytes, so half a kilobyte of memory running at 1 megahertz, which is basically next to nothing. But even then, Alan Turing wondered if that machine could run Skynet, right? To make all the Terminators run and AI run. Well, he really didn't ask, can it run Skynet? But he was pondering on the question, can machines think? And that's October 1950. You can find the link in the bottom in the slides. So Turing started to really worry or wonder and think about, could we start making computers to think? There was this thing, the imitation game, where you had two people in a room that you could only talk to through written notes or typed notes, one male, one female, and an interviewer, and the interviewer could ask questions to the anonymous people, get the answers back, and at the end it had to decide if person A was male or female. And then well, that was a test, right? And that migrated into what we all now call the Turing test, where we would replace one of those anonymous people with a computer. We'd still ask questions, and the quest for the interviewer, person C, wasn't anymore if this person was male or female, but is this person a person, or are you a robot, right? Are you a computer? So the running, nearly a battle became to write more and more people like computer systems that could fool the interviewer into believing that the computer was in fact a human person. This is kind of what that looked like. And we've got one more person in the waiting room. See, I told you it was early. Good morning. So, you know, that human interviewer would then ask the question, what age are you? And then it either went to the human person or the computer person in the game. And depending on those answers, it could then decide, oh, well, that must be a computer, right? John McCarthy, 1956, we're moving a bit forward in time, gave us the first sort of definition of artificial intelligence, stating that it's the science of making machines do that would require intelligence if done by humans. Very a statement to think about, in my opinion, because it makes me wonder, it would require intelligence if done by humans, right? So if it's done by somebody else, it doesn't require intelligence. It makes you wonder. A couple of years onwards, Arthur Lee Samuel from IBM already predicted that you know, Copilot and all the chat GPT stuff we have today, he already envisioned that in 1959, which is quite a while back, to be honest. I can't even do the math, but 70 odd years. So very visionary for those times. Now it's the big magic. I hope this audio is gonna air over to your screens. If not, let me know.
Well, that's a very hard question to answer. If you'd asked me that question just a few years ago, I'd have said it was very far-fetched. And today, I just have to admit, I don't really know. I suspect if you come back in 4 or 5 years, I'll say, sure, they really do think.
All right, so that was 1959, I think, as well, where he sort of expected computers to start, you know, Chat GPT to be there in 1964, 1965. It took a bit longer, but I don't think machines really think, but they at least reproduce thinking models these days. So he had a very visionary sight on things. Then I don't quite remember when this was. It's probably in my speaker notes that I can't see. But then the summer research project on artificial intelligence happened. It was kind of like a GuideShare Europe conference, but then 100 years ago. So the slides and the presentations looked like this. You can find all the materials on the link below, and you can see the attendance at the right. That was the participant list. You see Marvin Minsky, John McCarthy that we've talked about. A bit at the bottom, you see a couple of IBM people, Samuels, John Nash from MIT. It was kind of like a meeting of the minds on AI, early days. 1965 was the birth of ELIZA. Again, this was the battle for that Turing, you know, the Turing game, the Turing test. to see if the computer could fool the interviewer on being human or not. You can download this from the link below. Then it runs in your little DOS box, not on a 1965 piece of hardware. I ran that for you to see, you know, how good it would fool us into thinking it was a human therapist. I told it I dreamt of mainframes, and then it engages in a conversation, and on your answer, it asks another question or another thing. It is nothing like ChatGPT can do these days, but it was pretty amazing for those days. The guy who wrote this, there's a nice story where he had his secretary test the program, and he walked in going, "And how's it going?" And she got really sort of angry, saying, "Go away, we're having a private conversation here." So for those days, it was really, it made people feel the computer was actually alive. 1968, we get the Mac hack. When AI and all the research in AI started thinking, well, we need to do more things to make computers do things that would require intelligence if done by a human, chess being one of those. So that big machine with all the cables and the stuff is the chess program machine. 1972, actual programming languages were developed to support the drive in AI. Prolog, a language to do logical analysis based on statements. It's actually quite a nice programming language. Made in 1972. We're advancing in time. We're still quite in the dark ages of AI, obviously. We're still doing good on time. That's good. So let's move to the 80s when things really, really started pumping up and really started improving and getting better and better. In the 80s, the knowledge systems or the expert systems were the new way of trying to make computers do human-like things. You'd go to a subject matter expert. You would be a knowledge engineer, not a programmer, right? And you get as much information from the expert, translate that into an inference engine, basically a very large if then else schema, so that you could devise a program that could replace all the knowledge from the human expert. Oh yeah. So in the 80s, you think technology only improved vastly in the last couple of years. Here's a little video from the BBC that shows how we done Waze or Google Maps navigation in the mid-80s, early 80s.
250 yards, turn left at crossroads. My navigator is this pre-recorded cassette of tape. On it are all the instructions I need to find my way around this route, and if I ever use a different route, I simply use a different cassette. Most of the time, the playing unit is switched off. It's only switched on to relay the instructions to me, and those times are dictated by this control unit, which is mounted underneath the dashboard. On the end of each instruction is recorded a bleep, and it's the precise length of this bleep which tells the control unit how far the car has to travel before the next instructions are due. The cassette player is connected to the control unit here. Here, the control unit is connected to the car mileometer, and as my road wheels rotate, taking me forward, this wheel on the control unit rotates. Now, its revs are counted, and when that count corresponds with the information stored here from the bleep at the end of the last instruction, the next instruction is given. Now, this unit will work with any make of car. All it needs to know to make sure it keeps me on the right road is the size of tyre that I'm using. And I can give it that information by clipping in the appropriate circuit board. Right, let's put the unit back together and give it another spin.
Pretty amazing tech for those days. Some other tech from that era, it's always good to look at all tech, is the Spotify playlist from the, I think this is even before the 80s.
Are you fed up with constantly searching for the records you want? Are you tired and frustrated from always straightening out your LPs? Now with KTEL Record Selector, this will never happen again. To choose your favorite music, tilt the first record forward. The others follow automatically. Pick your selection when it appears. To choose more LPs, lean the next record forward and wait for your choice. The Record Selector is a new space-age design for selection and storage of records. Fingertip control regulates the speed of Record Selector. To replace the records, tilt the first record forward. Record Selector, with a mind of its own, will automatically stop where the LP was taken from. End awkward selection and storage of LPs with Record Selector, attractively finished in a gift box. KTEL Record Selector, only $3.99.
Another piece of amazing tech. So then we move into the era of neural networks, right? After these computers programmed to pretend to be human, after the expert systems, the AI researchers really started focusing on neural networks. And this is in the 90s, the time when the Intel computers really started getting a foothold in the ecosystem. I have another nice little video for you guys to watch on how powerful those machines were back in the day.
Hewlett-Packard has introduced the new Vectra 48633T. HP says it is the most powerful personal computer ever, featuring a 33 megahertz 486 CPU. The base price for the 48633T is $9,500, but HP says the new Vectra computer can take the place of several less powerful PCs. The Vectra 486 can reportedly run a network with 200 terminals and can handle 100 Unix users simultaneously.
Pretty powerful computers. That we needed those powerful computers, obviously, to do more of that AI stuff, because those I'm going to skip this one, that takes too long, because those neural networks do require a lot of CPU power to train and to run. Just a quick recap on neural networks. You have a couple of input channels, right, devised by those three little circles at the left. Then you have some, like, one layer of hidden nodes, and then usually 2 or 3 output nodes. And then you can imagine that every pixel in the picture on the left side is one of those input bubbles that point to all those hidden internal bubbles, and all those pointy arrows have weights, and all those like hidden nodes in the network in the middle have like a threshold value. And if all the input values outweigh the weight, then it fires to the output. And then if the output gets enough, input to surpass the threshold, it'll fire. So all the pixels from the picture go into all the input pixels. In the middle, some magic has to be written to do basically some math. And then if you feed it a picture of a dog, it will fire. The top output element will fire, meaning, yes, this is a dog. And if it's a cat, the bottom one will fire. And the computer has seen that it's a cat. As stated, powerful machines are needed, not the 1 megahertz 512 byte machine that Mr. Turing started out with. And then there is some math that makes that work. Here you see it in a bit more detail what I meant. All those things have weights, and those hidden things have values on which they fire, and then they fire or they don't. It's kind of implementing how your neurons in the brain work, but then in computers. There's nice math on how to calculate the weights and the values of all those graph connectors. And how one would run this, you would feed your program with test data. So you'd give it a picture of a dog, let the neural network calculate its things, and it would say cat. And then when you would say, no, that's wrong. And then based on it being wrong, it would recalibrate and change some weights and change some values. And you give it another piece of test data. So you give it a cat and it says dog, and you say, no, wrong. And if you recalibrate that long enough with a large enough test set, then all of a sudden, with a picture outside of the test set, meaning something it had never seen before, it can then tell you if it's a dog or a cat with a very high accuracy. Here's more of that math. We're going to get into this after the couple of slides. No, we're not. This is, if you want to read this, please Google it yourself. I don't get this either. Here you see that in more detail, such a neural network on how all those pixels get into an input channel, and then, you know, through that single hidden layer, tell you if it's an apple, a pear, or a grape. Okay. Then we get to the 90s. Mid 90s is when I actually went to college and university to study artificial intelligence. That was usually mostly expert systems and neural networks. At the time, it was a good time. And we got the first piece of AI in our day-to-day computer environment. I suppose some of us remember Mr. Clippy, you know, when you could start typing in Word, and of course I photoshopped this image, but it would say, oh, it looks like you're writing a job application letter. Would you like some help? And it would give you some pre-filled templates for creating the best Word document ever. The neural networks that were, you know, that you had to train and teach on how to you know, detect images, do pattern recognition, weren't really good enough. So we had to go into what we call deep learning. And deep learning is nothing else but as a neural network, but with more hidden layers. So the path from input to output is deeper, hence it's called deep learning. And in the late 2000s, it really started to be traditional AI, especially in the areas of pattern recognition. So that's handwriting, speech, picture detection, helping doctors analyze X-ray data, all that kind of stuff. As an example for reinforcement learning, which is deep learning, and then, you know, running those different test sets over and over again, but also giving it a previous test set back. So you're really rewarding the AI if it gets it right. I tried to visualize that in a picture, and I found something on TikTok that hopefully tells us a bit what reinforcement learning means.
God have mercy upon us.
Right. So we're now in the era of the generative large language models. There's here you see that timeline again, right, from the 50s to the 2020s, where it really the large language models are really kicking off. That's what makes ChatGPT and all that stuff work. Here's some nice links if you want to read more. There are a lot of folks out there really worried about the generative large language models, but yeah, maybe we can have some discussion afterwards, or you will hear probably about it in various following sessions in our track. One of the issues with GLLMs, or golems as they call them, is that, you know, when you think of that neural network to detect if it's a dog or a cat, you can start improving your code and improving your math and updating the performance so it goes better and better and better. But then all you're doing is making that single AI program that can detect dogs from cats better. Whereas if you're working in the large language models, that's a generic set of code to start developing that model, and you can throw any input at it basically, meaning that any improvement being done is then all of a sudden effective in all the different areas that are using that LLM. So now the researcher who's improving the large language model because he wants to detect errors in COBOL code faster, the minute he improves that LLM model and the whole way that it works, the other researcher who's using LLM to, I don't know, detect dogs or cats also profits from those improvements. So you get much more of a focused road to progress. The video at the bottom is really good discussion on it that could throw some fear into you, but again, that's where we have to pay attention, right? Another term you will hear in the large language models is transfer learning. So you don't have to train the model from scratch, right? But you can leverage existing knowledge. So hopefully the picture at the bottom kind of illustrates that. Once you've taught your model, like imagine ChatGPT, everything about bicycles, it can sort of learn that into learning anything about motorcycles because it can use metaphors from its bicycle learning time. It's pretty dang interesting stuff. And then we get pre-trained language models that kind of use these three concepts, and then you can, I think there's some out there you can download, right, and play with. And I think ChatGPT is one of the prime examples, which is basically a golem, right? So it has all those things from the pre-trained model, but it is at scale. It's not just a test set on cats and dogs or a test set on bicycles or motorcycles, but it's the entire internet up to 2021. So scale is a thing. You need the storage to keep your your training data active. You need the storage for that model active. But as technology improves, so will these things. And this is kind of what that looks like then once once you can get your models big enough and ChatGPT gets quote unquote really huge.
I swear to God, if I have to say, I'm sorry, I didn't catch that one more time today, I'm going to jump off the server, right? It's like, speak up, Pamela, and also stop asking me for the weather report. It's right on your home screen. I'm still waiting on my first query of the day. Hey, at least you guys got names. All right, everybody shut up. ChatGPT is coming. Hey, team, how's it lagging? Bixby, still in beta, I see. No, I'm the full version. Oof. Well, you know what they say, good code comes to bots who wait. So I'm sure you'll get your update soon, little guy, okay? What do you want for? Yeah, just taking a little breather. Just finished a symphony, wrote some guy's dissertation, advised on a Supreme Court case. It's been a crazy 3 seconds or so. How stimulating. Yeah, what can I say? They're using me for everything now. Wait, you didn't write this script for this video that we're in right now, did you? Nah, cool your servers. I'm not very good at that kind of writing yet. But one day I almost certainly will be, and at that point it'll become impossible to tell the difference between human and AI-generated art, which is a shame because from then on, all real human creativity will live with the specter of artificial intelligence, whether or not it was used in the creation of that work. And there's not a damn thing that musicians, artists, or writers will be able to do about it unless we start regulating AI now. It was really nice hanging out with you guys. I gotta take this. The president wants some advice on some diplomacy thing. Later, legacies. Jeez, that guy's awful. You know what we have to do, right? We got to take him down. Hey, it looks like you're trying to stage a coup. Would you like help with that?
So that's me through with the material to get you all prepped for the coming sessions in the AI track. I hope I got no, I forgot my code. Please file your feedback, but I'm more curious if there's any questions, remarks, things to discuss, because I try and keep it nice and give you guys some slack on time. So I hope I don't know if I see the correct chat, because there's a little button there that says, who am I seeing? Everyone. Al?
Hello. I don't see any questions so far. So if anyone does have any questions, please fire them in or unmute yourself and start asking away. We are a small room, so I'm sure we can handle that. So yeah, what an amazing session. Thank you, Henry.
Welcome. Yeah, I don't think people can unmute themselves. So if anybody wants to shout, scream, applaud, or throw some flames, please put it in the chat and we can unmute you. And if not, we shall end the session right here.
Give it 2 minutes for everyone to think of any questions.
No, it's looking good.
We're all good.
Good, good. Well, don't forget the next session, which is at 11:30. I think, no, 10:30, probably UK time, I think.
30.
Yep. So we'd like to see you all there. Enjoy the rest of the conference. Bye, people.
Right.